In this video, I will talk about, or I will give you a numerical example of Hall electric field and electric potential. So what we have here is a sheet, a silver sheet here. This silver sheet carries a current, and this current is, let's say, we can call this one x-axis here. Let's call this as an x-axis, and we call this as an y-axis, and this will be our g-axis. Okay, that's the x, y, and g. So the current is passing through this silver foil along the direction of x. The magnetic field, and this one is placed in a magnetic field which is directed along y-axis, and this will be our g-axis here. Then you need to find out what is the magnitude of Hall electric voltage and electric field here. The given quantities are the current. The current that is passing is 200 ampere. And we know that the magnitude, the charge of an electron is given by this number here, negative 1.6 times 10 to the minus 19 coulomb. That's the charge of an electron. And it is placed in an external magnetic field of 2 Tesla. The charge carrier density of the silver is given by this number here, 6 times 10 to the 28 per cubic meter. That if you just take 1 cubic meter of silver foil or silver, then you will have this many electrons. Now the area is given 1 centimeter by 5 centimeter. And here I have chosen the t equals to 1 centimeter here. This is the 1 centimeter, and this has to be 5 centimeter. Now we know that the equation for calculating the Hall voltage is given by this equation here, I, B, and QT. And here we are interested in finding out only the magnitude. I is the current. This is given by 200 ampere. B is 2 Tesla. N is 6 times 10 to the 28. Q is 1.6 times 10 to the minus 19. And T is the 1 centimeter. And you might be wondering why 1 centimeter, not 5 centimeter, because this is 5 centimeter and this is 1 centimeter. When you write down this dimension, this number, this dimension has to be along the dimension or along the magnetic field. Okay, so this dimension has to be in the direction of the magnetic field. And look at here, the magnetic field is applied along g direction. So the vertical direction here is 1 centimeter. So we have to choose this centimeter. All right. So once you plug in all the values and make sure that the t is in meter, you have to change it to meter. What you get, the Hall potential or Hall voltage is 4.2 times 10 to the negative 6 volts, which is 4.2 microvolt. And see now, so this potential will be developed in the direction of both electric field and magnetic field. So as I mentioned, this has to be in the direction perpendicular to both electric field and magnetic field. So this direction is the current. This is along the magnetic field is along a g direction. So the Hall electric field will be between these two surfaces here, between this surface and between this surface here. Okay. So this side and this side here will have the Hall potential. And now once we know, and I haven't shown here the electric field here, so let me erase this one. Okay. So now we have to find out the magnitude of the electric field. The electric field magnitude is given by EH, that's the electric field, potential difference divided by the distance here. In this case, as the Hall potential is developed between these two sides and the distance between them is 5 centimeter, so we have to take this dimension here, 5 centimeter. And once you do the math, you will get this electric field is developed across these two ends here. Okay, so you see, calculating the magnitude of the electric field, Hall electric field or Hall potential is quite easy. The only thing that you have to keep in mind is which dimension you have to take. In Hall voltage, when you're calculating this Hall voltage, this dimension is always the dimension parallel to the electric field. When you calculate the Hall electric field, this dimension, this distance is always in the direction of the Hall potential, or between the two ends in which the potential Hall potential is created. So this is it from this video. If you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.